To us modern folk, we tend to take for granted the existence of cells and the idea that all living things are made up of cells, that we, as human beings, as living organisms, we're made up of many, many, many cells. And the estimates of the cells in the human body are on the order of 37 trillion cells. But if we were to rewind even 400 years ago to the 1600s, this wasn't so obvious. And that's because people really didn't have the tools to make direct observations of cells. They didn't know that these cells were around. They didn't know that things even like unicellular organisms even existed. But all of that began to change with Robert Hooke. Robert Hooke was able to leverage primitive microscope, and this is a picture of his microscope. But when you see this, you appreciate how, at least relative to what we have today, how primitive it was. He had lenses here that would provide some magnification, but he had to use this right over here. This is a flame, and he's able to channel that light so that it gets reflected over whatever he's observing. And in 1665, he publishes the Micrographia. I'm probably not pronouncing it right. So this is 1665. Robert Hooke publishes this, and in this he describes and he draws a lot of his observations using his microscope. And he has some fascinating drawings. He was actually quite a good artist, where he's able to draw pictures of his observations of things like lice and fleas. But it's not just lice and fleas that he's able to observe. He actually takes a look at some cork cell, or what he just sees as cork. And when he makes that observation, he says, hey, look, there are these little squares over here, and this kind of seems to be somehow kind of a basic unit of this cork. And he says, well, this kind of reminds me of these little rooms that monks live in and spend their time in, which we call cells. So he calls these cells, and that's where the word comes from. He calls them cells in Micrographia. That is a cell. Now, unfortunately for us, he was a great artist, or he was really good at drawing things, and he drew a lot in his Micrographia, but we don't have any pictures of Robert Hooke anymore, and it's a fascinating story. Most theories are that actually it was Isaac Newton burned the only original painting that we have of Robert Hooke, and that's another intriguing story that we can talk about at a future date. But what Robert Hooke, he coined these things cells, but he was looking at dead tissue, and actually he was looking at the remnants of cells, and what he saw was really just the cell wall remnants. He wasn't actually able to observe directly living cells, and he didn't have enough to go on to think, hey, maybe this is a building block of all life, and maybe cells themselves reproduce, and all cells come from other cells. And that doesn't start to get developed until we get further on into history. You go a few years later, we get to Antony van Leeuwenhoek. I know I'm not probably pronouncing it right, but he was a Dutch lens crafter, and he was inspired by Hooke's work. And he says, well, hey, I can craft lenses. Maybe I can use that to make better microscopes and make better observations. And he was able to do that. And doing that, he was able to directly observe living cells and living unicellular organisms. So he was able to directly observe sperm and say, wait, this thing looks like it's alive. He was able to directly observe protists. So these unicellular eukaryotic, they have cell walls, these things that look like unicellular animals. And he called them actually animalcules. Animalcules. Saying, hey, look, these look like these little mini animals going on here. And so he started to say, well, maybe this is some form of a basis of life, or at least he's trying to say that these at this very small scale you actually have life. But a fully modern theory of the cell doesn't really start to emerge until we get another 150 years into the future, and we get into the early 1800s. So if we fast forward to the 1830s, these two gentlemen, Matthias Schleiden and Theodor Schwann, come into the picture, and they're the ones that start laying the foundation of what we could call modern cell theory. So modern cell theory. And using their observations and kind of what they were able to deduce, they said, hey, maybe all living things, all life is composed of one or more cells, one or more cells. And today we kind of take this for granted, but this wasn't obvious. It wasn't obvious that all things, that this was somehow a building block for life, one or more cells. And then following that, if all life is composed of one or more cells, you could also say that a cell is the basic unit of life. Cell is basic unit of life. And these are strong statements that all life, if you were to get down small enough, you're going to come to cells, living cells that make up that life. Now, this isn't our full, complete cell theory, and both of these gentlemen, they knew that cells could come from other cells. They were able to observe cells reproducing, but it still was an open question. Hey, maybe some cells come from other cells, while others, maybe they somehow get spontaneously created if you have the right elements and the right amount of conditions. Maybe they somehow just emerge out of nothing. And it wasn't until this kind of third tenet of modern, it wasn't until the mid-1800s that we get our third tenet of modern cell theory that gets established, and this is this idea that all cells come from other cells. All cells from other cells. And the real father of this idea, the one that really established this, is this gentleman right here, Robert Remak. Now, sometimes the credit for this goes to Rudolf Virchow right over here, but it turns out that he plagiarized Remak's work. He plagiarized Remak's work right over here. So it's really Remak who deserves the bulk of the credit for this tenet that all cells come from other cells. And once again, he wasn't the first person to say, hey, we'll observe that some cells come from other cells, but say, no, this is a fundamental thing. All cells, this is how they actually come about. They aren't just somehow spontaneously emerge. Now, whenever, even in today's world, people see this last thing, all cells come from other cells, there's a natural question, well, there must have been a first cell or an initial set of protocells, and people aren't 100% sure. But when we look back at the evolution of life on Earth, we think the first cells emerged about 3.5 billion years ago. And we're not 100% sure about how they emerged, but there are some theories. For example, we have videos on phospholipids, and it turns out that phospholipids naturally form bilayers. So phospholipids naturally form bilayers. And they can actually form spherical membranes that have phospholipid bilayers. So that kind of gets you a start. So that can spontaneously form. And there's also theories that maybe the information, the machinery of cells, maybe their ancestry, if we were to go 3.5 billion or longer ago, that it might have been, maybe it was self-replicating RNA molecules, or maybe it was somehow self-replicating proteins that over time, over very large time scales, were able to start replicating themselves, have more sophisticated machinery. The ones that kind of were approaching our modern cells were able to reproduce more, were able to take advantage of kind of more of the energy, the resources in an environment, so that we eventually get with our modern cells. But this is a fascinating question, and it's still an area of research.